Silica fume, also known as microsilica, is an amorphous polymorph of silicon dioxide, silica. It is an ultrafine powder collected as a byproduct of the silicon and ferrosilicon alloy production and consists of spherical particles with an average particle diameter of 150 nanometers. The main field of application is as pozzolanic material for high-performance concrete. It is sometimes confused with fumed silica. However, the production process, particle characteristics and fields of application of fumed silica are all different from those of silica fume. History: the first testing of silica fume in Portland cement-based concretes was carried out in 1952. The biggest drawback to exploring the properties of silica fume was a lack of material with which to experiment. Early research used an expensive additive called fumed silica, an amorphous form of silica made by combustion of silicon tetrachloride in a hydrogen-oxygen flame. Silica fume, on the other hand, is a very fine pozzolanic, amorphous material, a byproduct of the production of elemental silicon or ferrosilicon alloys in electric arc furnaces. Before the late 1960s in Europe and the mid-1970s in the United States, silica fumes were simply vented into the atmosphere. With the implementation of tougher environmental laws during the mid-1970s, silicon smelters began to collect the silica fume and search for its applications. The early work done in Norway received most of the attention, since it had shown that Portland cement-based concretes containing silica fumes had very high strengths and low porosities. Since then, the research and development of silica fume made it one of the World unregistered trademark's most valuable and versatile admixtures for concrete and cementitious products. Properties: silica fume is an ultrafine material with spherical particles less than 1/1/4 m in diameter, the average being about 0.15 I/1/4 m. This makes it approximately 100 times smaller than the average cement particle. The bulk density of silica fume depends on the degree of densification in the silo and varies from 130 to 600 kg per meter 3. The specific gravity of silica fume is generally in the range of 2.2 to 2.3. The specific surface area of silica fume can be measured with the BET method or nitrogen adsorption method. It typically ranges from 15,000 to 30,000 m2 per kilogram. Production: silica fume is a byproduct in the carbothermic reduction of high-purity quartz with carbonaceous materials like coal, coke, wood chips, in electric arc furnaces in the production of silicon and ferrosilicon alloys. Applications: concrete because of its extreme fineness and high silica content, silica fume is a very effective pozzolanic material. Standard specifications for silica fume used in cementitious mixtures are ASTM C1240, EN 13263. Silica fume is added to Portland cement concrete to improve its properties, in particular its compressive strength, bond strength, and abrasion resistance. These improvements stem from both the mechanical improvements resulting from addition of a very fine powder to the cement paste mix as well as from the pozzolanic reactions between the silica fume and free calcium hydroxide in the paste. Addition of silica fume also reduces the permeability of concrete to chloride ions, which protects the reinforcing steel of concrete from corrosion, especially in chloride-rich environments such as coastal regions and those of humid continental roadways and runways and saltwater bridges. Prior to the mid-1970s, nearly all silica fume was discharged into the atmosphere. After environmental concerns necessitated the collection and landfilling of silica fume, it became economically viable to use silica fume in various applications, in particular high-performance concrete. Effects of silica fume on different properties of fresh and hardened concrete include: a. Workability: with the addition of silica fume, the slump loss with time is directly proportional to increase in the silica fume content due to the introduction of large surface area in the concrete mix by its addition. Although the slump decreases, the mix remains highly cohesive. b. Segregation and bleeding: silica fume reduces bleeding significantly because the free water is consumed in wetting of the large surface area of the silica fume and hence the free water left in the mix for bleeding also decreases. Silica fume also blocks the pores in the fresh concrete, so water within the concrete is not allowed to come to the surface. See also, engineered cementitious composite, energetically modified cement, fly ash, kaolinite, pozzolan, rice husk ash, metakaolin. References. Further reading, U.S. Federal Highway Administration. Silica fume. Retrieved January 24, 2007. Portland Cement Association. Chapter 3 Fly ash, slag, silica fume, and natural pozzolans. Retrieved April 7, 2012. Silica Fume Association. Silica Fume Users Manual. Retrieved May 5, 2012. External links, Silica Fume Association.